Firebase Real-Time Database with ESP32 and DHT11. In this lesson, we'll guide you through the swift setup of Google Firebase and its seamless integration with your ESP32. In this step-by-step lesson, we'll walk through the process of creating a project to store and retrieve values from the Firebase Real-Time Database using your ESP32. The entire demonstration will be conducted using the Arduino IDE for coding your ESP32 and showcasing these operations in real time on your database. By the end of this lesson, you'll possess the skills to independently execute experiments, saving input data of diverse types, such as integers, floats from sensor like DHT11. Firebase is Google's robust mobile application development platform designed to empower you in building, enhancing, and expanding your app. Offering a comprehensive toolkit, Firebase comprises various services tailored for efficient data management across Android, iOS, and web applications. This all-encompassing tool set encompasses analytics, authentication, databases, configuration, file storage, push messaging, and more. A notable advantage lies in its cloud-hosted services, which seamlessly scale with minimal effort on the part of the developer. In this demonstration, we will craft a Firebase project equipped with a real-time database. Leveraging the capabilities of the ESP32, we will seamlessly store and retrieve data from this database through Firebase. Notably, our ESP32 device gains the ability to interact with the database globally, as long as it maintains a connection to the Internet. Components required: ESP32 Development Board, DHT11/DHT22 sensor, connecting wires, a micro USB data cable. Circuit setup: connect the DHT11 sensor. DHT11 has 3 or 4 pins: VCC, GND, and data, and sometimes NC. Connect VCC to 3.3V or 5V on the microcontroller. Connect GND to the ground, GND, on the microcontroller. Connect the data pin to a digital input pin, e.g., D4 on the microcontroller. Steps to set up Firebase Real-Time Database and ESP32. 1. Log into Firebase. 2. Create a new project. 3. Set up authentication. 4. Create a real-time database. 5. Add variables. 6. Retrieve project API keys. 7. Program Sketch in Arduino IDE. 8. Install ESP32. Install and include Firebase and sensor libraries in Arduino IDE. 9. Upload Sketch. 10. Monitor database. To use the Arduino IoT Cloud, follow these detailed steps. 1. Log into Firebase. Visit Firebase website. Navigate to firebase.google.com. 2. Create a new project. Sign in and start a new project. Log in with your Google account. Click Get Started to create a new project. Press Add Project to initiate a new project setup. Name your project. Give your project a name, e.g., Lesson12 ESP32 RTDB. Click Continue. Configure Google Analytics optional. If not using Google Analytics, disable the option. Click Create Project. Wait for project setup. Allow some time for your project to be set up. Continue to Project Console. Once ready, click Continue to access your project console. 3. Set up authentication. Set up authentication. On the left sidebar, select Authentication. Click Get Started. Choose Sign-in method. Under the Sign-in method tab, select your preferred sign-in providers, e.g., email, password, phone, etc. For testing, enable anonymous sign-in. Click Save. 4. Create a real-time database. Create real-time database. Click Build real-time database. Select Create Database. Choose Database Location. Choose the location for storing your real-time database data, preferably close to your physical location. Click Next. Set up security rules. For quick setup and testing, choose Start in Test Mode. Click Enable. Copy database URL. Copy and save the provided database URL in a notepad for later use in your ESP32 code. 5. Add variables. Add 2 variables for temperature and humidity. 6. Retrieve project API keys. Click the gear icon on the left sidebar. Select Project Settings. In the General tab, locate the Web API key. Copy and save this key in the Notepad. 7. Program Sketch in Arduino IDE. Write or download the sample DHT11 code with Firebase and ESP32. 8. Install and include libraries in Arduino IDE. Install ESP32 and select ESP32 Rover module as the board. Install and include Firebase and sensor libraries in Arduino IDE. 9. Upload Sketch. Connect your ESP32 to your computer. Upload the verified code to the ESP32. 10. Monitor database. Once the device is online and connected to Wi-Fi, open the dashboard to monitor the devices. Programming instructions. 1. Include necessary libraries. Use Arduino.h, Wi-Fi.h for ESP32, or ESP8266 Wi-Fi.h for ESP8266. Include Firebase client library and helper headers. 2. Define network and Firebase credentials. Define Wi-Fi SSID and password. Define Firebase API key and RTDB URL. 3. Initialize Firebase and Wi-Fi. Create Firebase data, authentication, and configuration objects. Set DHT sensor pin and type. Initialize DHT sensor. In setup function, begin serial communication. Connect to Wi-Fi and print connection status. Configure Firebase with API key and RTDB URL. Sign up to Firebase and check for successful sign-up. Set the token status callback function and start Firebase. In loop function, delay between readings. Read temperature and humidity from DHT sensor. Print temperature and humidity values. Check Firebase connection status and send data to Firebase RTDB if ready. Saving sensor data from ESP32 to Firebase RTDB. 1. Periodic check and sign up. To send data to the database, periodically check if Firebase is ready and if sign-up is successful. Perform this check every 5 seconds or at the start of the loop. Reassign a new release value to the send data print mail list variable when it exceeds the 5-second interval to restart the 5,000 millisecond counter. 2. Reading and storing sensor data. Read DHT11 pin for humidity and temperature of type in /float. Calculate the analog voltage reading and store it in the voltage variable of type float. Convert millivolts to volts by dividing by 1000. Use Firebase functions to store data in the RTDB. For integer data, use setInt. For float data, use setFloat. Check the success of the operation. Print the stored data path, value, and data type if successful, or print the error JSON if it fails. 4. Checking data in Firebase RTDB. Verify in the Firebase RTDB console that data is successfully stored under the specified paths. Note that the database blinks when new values are saved every 5 seconds. 5. Testing sensor data. 6. Controlling LEDs based on RTDB data. Understand that data in Firebase is stored as JSON objects. Set keys and values under a node, e.g., LED, in the RTDB console. Read and control LEDs in the ESP32 based on RTDB data. Use PWM for analog control and a Boolean value for digital control. 7. Code organization. Organize the code by defining constants for PWM channel, frequency, and resolution. Declare variables for storing PWM value and LED status. In the setup function, initialize the LED pins as output and set up PWM. In the loop function, read RTDB data to control LEDs, ensuring instant updates.